Hello and welcome to another video. Today we're going to be working on minimum AscII delete sum for two strings. In this problem you're given two strings S1 and S2 and you want to return the lowest AsCII sum of deleted characters to make the strings equal. So you have S1 equals C, S2 equals EAT. So for this example let's draw that out. So C, EAT, and you can see what you're going to want to do here is you're going to delete this S and this T. And so the cost of that is 115 and 116. And for the second one, we have delete, and we have leet. So you can see here, you're going to want to keep this leet for both of them, and then you're going to want to delete the rest of it. And so when you do that, when you delete this part and this, you get 100, 101, 101, and then you delete the E from the last part. So this problem is kind of similar to the longest consecutive subsequence or something, like one of those, where essentially you have two strings and you're trying to find the longest shared substring. So let's get some intuition here. So first of all, we have 1,000 characters. So right away, what you're going to want to do, step one for these, a little bit harder problems, you're going to want to look at the constraints. So we have 1,000. So what algorithms can we consider? We can consider n squared. Probably like n squared log n, something along those lines, right? And then anything better than that will pass. Anything worse than that will fail, roughly, because n squared is like 10 to the 6th. So the first thing you want to be doing for these kinds of problems is ask yourself, is it like a contiguous substring, or is it a subsequence, or what are we doing here? And here we're going to be deleting from all over the place, so it's not going to be contiguous. So if it's not contiguous, right away, if it is contiguous, try to do an array, right? Like a sliding window type of situation. And if it's not, then try to do DP. And so can we do this with DP? Let's try to figure it out. Like what would be our constraints and what are we even doing, right? So essentially, at every single point, we can choose to delete a character or not delete a character. And so let's see what that's going to look like. For example, for this like C and EAT. So we're going to start like here. And we're going to say we can delete or we can not delete, right? And so let's actually maybe draw a tree for the simple problem. Let's actually delete all this and let's just draw a tree for this type of situation. So we have C and EAT. This shouldn't be too big, so we should be able to do it. So EAT. Okay, these are our two strings. All right. So in each case, we can choose to delete one of the characters. Well, let's just think about it, right? So to make strings equal, we have to, if the letters aren't equal, we have to delete one of them, right? We can't just keep going, because then we'll never get a valid solution, right? Like let's say we keep going, like we just do nothing, we just keep going. Then this S, they're going to start with S and E. So if they're different, we have to delete one of them. So let's just say on the left, we're going to delete the S, right? So we delete the S, that has some cost. We'll write that cost S. So we're going to have EA now left. And on the right, we're going to keep it the way it is, right? Or actually, sorry. So this is going to be EA for the left one. And then the right string is going to remain as EAT. So let's actually draw EA here. Yeah. Let's draw EA. And then EAT. Okay, so these are two strings now. We're going to actually be indexing into these strings, but this is going to be like what it's going to look like, essentially. Now for the second one, let's choose to delete from the right. So we're going to have SEA, and then we're going to delete from the right, so now we're going to have at. And we just deleted E, so whatever the cost of E is. Okay, so now in this left side, let's do this left side first. Now this E and E are the same. So if they're the same, we don't want to be deleting, we just want to like move on, right? So we want to just move on both of them because they're the same characters, so there's no reason to delete. So now there's only going to be one choice here. We're just going to say, let's just move on both of them. So now we have the A, and then we have the AT left over. Okay, and let's actually finish this left side first. So now for this A and this A, they're equal again. And so we can just move on. So now this is going to be the empty string. And this is going to be T. And so now you have an empty string in T, and how do you make those equal? Well, you have to delete the T, right? There's only one thing you can do there. So we're going to delete the T here. And now these are finally going to be both the empty string. So actually, we're going to delete the t over here, right? We're not going to delete it up there. We're going to delete it in this step here. Delete the t, and now these are both empty strings. So that's like a base case. Okay, now let's go to the left. So these are different once again. So we can either delete the s or delete the a, either one. Okay, so let's just delete, we'll delete each one. So if we delete the s, we deleted s, and now we have ea and at. And if we delete the a, then we have SEA, and we have AT. Okay. Now for this EA and AT, they're different again. So we can delete either the E or the A. So let's say we delete the E, we're going to have A, and then AT. And we deleted the, what letter did we delete? We deleted the E. And then here on this right side, we're going to delete the A, let's say. So we delete the A. Then we have EA and T. Okay. And now here, they're the same, so we can just move on. So this is going to be the empty string. And this is going to be T. Now, there's only one choice here, right? We have to delete the T to make them equal. So now we have two empty strings. Okay, so that one's done. Now for this left side, we have the EA and a T, and so we can either delete the E or the T. Let's say we delete the E. So we delete the E here. So we have a T, and then if we delete the T, right, then we have EA and an empty string. Okay, so now for this AT, we can either delete the A or the T, right, and then we have to delete the other one. But either way, we're going to delete one and then the other, so let's just say we're going to delete A and T, and then they're going to both be the empty string. You either delete the A, and then you have an empty string, you have to delete the other one. Either way, you're going to have to delete both of these letters to make these equal. Okay, and then here we have EA and the empty string. So to make these equal, we also have to delete E, and then we have to delete A, right, to make this equal to the empty string. So we're going to delete E, and then we're going to delete A. And we're going to make that equal to the empty string. Okay, so I'm not going to draw out the rest of this, but you can kind of see what's happening here. You're essentially either deleting, let's write this down, right, our steps. So essentially you are either deleting from the right, or from the first string, or the second string, if the characters are different. And then we can just write down the cost of that deletion, right? Like we can just say, let's just write down the cost of that deletion. And then if they're the same, we just move on, right? Because there's no need to do any deleting. And then finally, if one string is empty, to make them equal, we have to delete all of the characters in the second string. Okay, so that's going to be kind of our recursive-ish situation where like we're deleting from the first string or the second string, and then if they're the same, we just move on, and if one string is empty, we make them equal, we have to delete from the other string. And finally, our base case is both strings are the empty string, right? Or like we've run out of bounds in both of them or something. And let's actually think about how long this would all take, right? So this would be a DP, and I think I would encourage you to do DP for like as a brute force once you're not like a beginner in LeetCode, right? You're not, like if you're doing two-sum, you're not going to try like an n-squared approach. So I would say for these more complicated problems, I would say use DP as like your brute force, because it pretty much is a brute force other than the memoization, and then see if you can come up with anything better afterwards. Okay, so let's say we do DP. What are our constraints? So it's pretty straightforward. We're going to have an I and a j, right, which is going to be the index in each string, right? So we're going to have an I and a j in our DP, and then if we know the index in each string, then we know how much more of the string we have left to cover. And so this I and this j, so remember the string is length 1,000 characters, so this would work, right? This would essentially be n squared, which is totally fine. So these are our parameters. So for DP, we need parameters, right? Okay. Now we need the base case, and there's going to be a few of these from what we did. So what are the base case? if one string is empty, we need to delete the other string, right, to make them equal. That's one base case. And then if both strings are empty, we can return 0 because they're both empty already. Okay. And then finally, we also have the visited, right? So if there's something in visited or in the cache, so if there's something in the cache, let's just return that. Okay. And then now let's look at the recursive case. So there's going to be two situations here. One, letters are equal. We just update I plus 1 and j plus 1 and move on. That's pretty straightforward. And the second case is if the letters are different, we minimize the result. And what's that actually going to be? So it's going to be the cost of deleting from I plus dp I plus 1, right? We go to the next letter in I, or the cost of deleting from j plus dp I j plus 1, right? So these are the two choices we have if the letters are different. And then everything else we have handled. We have if one of them is empty string, if both of them are the empty string, if they're in the cache, or they're the same, right? These are all the choices we have. And then finally, that's pretty much going to be it. So we have the parameters, we have our base case, and we have the recursive case. And now we have enough to code it up. Okay, so let's do that. So what do we need? We need the cache, right? So we can just call that visited equals default dict int. And then we can have our dp function. So we can say def dp. Yeah, I think for these kinds of problems, I'm just going to try to use shorter variable names just to make the coding easier. But I'd say for coding interviews, make sure to use variable names that are more descriptive, because those are things that are going to be good. Like you don't want to choose dp, l, r, and things like that. You want to have more descriptive names, because if you were to work in a code base, they don't want you to have this kind of stuff, right? It would be kind of annoying. Okay, so we're going to have def dp, and then we're going to have a I and a j, right? So that part is pretty straightforward. And what are our cases, essentially? So if our stuff is in visited, let's do that first, because there's like a lot of other stuff. So if ij is in visited, or let's just call that v, return vij. Okay. Now we have some more cases. So let's say I is length of S1. That means we went through the entire first string. So if I equals length of S1, that means we went through the entire first string. So then we have two cases here. If j equals length of S2, then we can just return 0, because that means we're done with both of the strings. Otherwise, we need to actually go through the rest of, or sorry, we have to actually go through the rest of the second string, right? We're done with string 1. We have to go through the rest of the second string. Now, what you could do is you could just loop through the second string here, but I'm just gonna pass it on to the next state. I think the time-wise, it's gonna be around the same. So you could loop through the entirety of whatever you have left in S2 from j to the end, and then just add up all those ASCII values. But I'm just gonna go to the next state in DP. So I'm gonna say else visited ij equals. So remember, we're done with I. So we need to get the value in j. So it's going to be, and by the way, in Python, if you want to get the ASCII value of a letter, use OR, and then you put in a letter. So it's going to be s2j plus dp of I j plus 1, right? So we're done with string 1. We're moving on in string 2. And you could do this in a loop to do the rest of it if you wanted to. Either one works. But the time efficiency isn't going to change. Okay. So now we have another case. We have if j equals length s2, that means we're done with j. So if we're done with j, we already checked for both of them being done. So now we pretty much have to have this condition here. If we're done with j, we have to be deleting from I until I is empty. You could also do this in a loop, or you could do dp, same thing. So s2i, right? And that's just to draw that out one more time. Like, let's say we have something like ABC left in string 1, but then, and we're like let's say we're on the letter A, but then we have whatever, like DEF left in string 2. We did a bunch of deletions, and now we're done with string 2. So if we're done with string 2, to make this equal to this, what we need to do is we need to actually delete every single character left in string 1. So that's essentially what we're doing, right? So that's the empty string case here, where we just said, like, we had a string and an empty string, and we're trying to delete everything else. Okay. So that part should be done there. Let me just double check here. So we need to be, so this actually needs to be I plus 1, right? Yeah, because we are deleting from string 1, and string 2 is done here. Okay, so those are all of our base cases. We can actually have like else ifs here. So we can just have an else if, because it shouldn't be both. And then we can have another else if. So the next case is if the two characters are equal. So if S1I equals S2J, that means they're equal. And so in that case, all we need to do is just move on to the next character, right? We're never going to be deleting. Like, if they're the same character, why would we delete? It's going to be cheaper to just not delete and move on to the next character. And that's always going to be the case. Okay. So that's just going to be dp I plus 1, j plus 1. Okay, and then finally we have like the everything else, So now we're on the case that the two letters are different and we have letters in both. And so now we're going to minimize that. So we're going to say vi j equals the minimize of, and so we can either delete from the right or delete from S1 or delete from S2. So let's delete from S1 first. So we can say like ord S1I plus dp I plus 1 j, or the other one, so ord S2j. Yeah, S2j, we're deleting from the second one now, plus dp I j plus 1. All right, so that's our two cases. We're either deleting from the right or the left, and we're just minimizing which one that is, as I showed in our picture. Now, finally, we can return this here, vij. Yeah, and I think that's going to be it. And so now we need to return, and then finally we need to call this function, and we need to pass in the 0 index to start off, right? So let's do that. See what happens. Probably have a billion errors. Oh, maybe not. Okay, nice. Okay, so it did work. And let's think of the time and space complexity here. And yeah, I think this problem is pretty straightforward. It's just like, can you figure out what it's asking? And once you can figure out what it's asking, I think it's a lot easier than like yesterday's problem with the printer and things like that. Okay. So for the time and space complexity, so we have n squared states essentially, right? Because assuming, well, I guess technically it's not n squared, right? So like, let's say S1 is length n, and then S2 is length m or something. It would be like n by m states, technically, because they could be different lengths. So let's just say something like that. And then all these operations are constant time, right? This is constant time, constant time, constant time, constant time, constant time, constant time. Okay, we don't have any loops or anything. We just have like 5 if-else statements. Okay. And for the space, it's going to be the same thing because we have n by m states, and we don't have anything else that we're saving. So yeah, I think that's going to be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next video. Thanks for watching.